Hello students, in yesterday's class we dealt about what is electrical circuit or network reduction techniques, and we also learnt about what is source transformation and source shifting, and we also learnt about one kind of transformation, that is delta to star. Today we will concentrate about how to convert a star into a delta transformation. In yesterday's class we read about delta to star. Today we will be concentrating on star to delta. I will give you a short glimpse what we derived yesterday. That is, if you take a star and a delta network, so I call the elements in delta network as ZA, ZB and ZC. Similarly, in star network I call it as Z1, Z2 and Z3. Yesterday we derived that how to convert a delta network into a star network. In star network the element is Z1. If you want to determine Z1, the elements connected to Z1 is ZA and ZB. So it will be equal to ZA into ZB divided by summation of all the resistance or summation of all the impedance, that is ZA plus ZB plus ZC. I call this as equation 1. Similarly, how to determine Z2? Z2 will be equal to Z, the two elements connected here are ZB and ZC. So it will be equal to ZB into ZC divided by ZA plus ZB plus ZC. I will call this as equation 2. Similarly, how to determine Z3? Z3 will be equal to, the terminals connected here are ZA and ZC. So Z3 will be equal to ZA into ZC divided by ZA plus ZB plus ZC. I will call this as equation 3. This is nothing but how to convert a delta into a star network. Today we will be concentrating on how to convert a star into a delta network. So star to delta means we need to determine what is ZA and what is ZB and what is ZC when Z1, Z2, Z3 are given. So what we do? Multiply equation 1 and 2. So if you multiply equation 1 and 2, that will be Z1 into Z2, which is equal to ZA into ZB square into ZC whole divided by ZA plus ZB plus ZC the whole square. Similarly, you multiply equation 2 and 3. If you multiply equation 2 and 3, that will be equation 2 is Z2 and equation 3 is Z3. So it will become Z2 into Z3 will be equal to, once again, ZA ZB into ZC square whole divided by ZA plus ZB plus ZC whole square. Similarly, you multiply equation 3 and 1. Once you multiply equation 3 and 1, that is Z1 into Z3, that will be Z1 into Z3 will be equal to ZA square ZB into ZC whole divided by ZA plus ZB plus ZC whole square. I call this as equation 4, equation 5 and equation 6. This is ZA plus ZB plus ZC whole square. Now what we need to determine? We know that from equation Z1 is equal to ZA into ZP divided by ZA plus ZB plus ZC. So in this equation it is nothing but ZA into ZB divided by ZA plus ZB plus ZC whole square. So you can represent this as Z1 into Z2 is equal to Z1 into Z2. Add these three equations. Sorry, one second. Add equation 4, 5 and 6. Once you add equation 4, 5 and 6, it will become Z1 into Z2 plus equation 5 is Z2 Z3 plus equation 6 is Z1 into Z3, which is equal to ZA ZB square into ZC plus ZA ZB plus ZC square plus ZA square ZB ZC, the whole divided by ZA plus ZB plus ZC whole square. So, once you get this equation, take ZA, ZB, ZC common. I will erase this. So, once you multiply, you have got Z1 plus Z2 plus Z2 into Z3 plus Z1 into Z3, which is equal to ZA ZB square ZC. So, in this equation, take ZA ZP ZC as common. So, it will be equivalent to Z1 Z2 plus Z2 Z3 plus Z1 Z3, which is equal to, take common in this equation ZA, ZB and ZC as common. If you take common ZA, ZB, ZC as common, then the remaining thing here will be ZB. So, in this term, if you take ZA, ZB, ZC square common, ZA, ZB, ZP as common, the remaining thing here will be ZC. In this term, the remaining term here is ZA whole divided by ZA plus ZB plus ZC whole square. In this numerator, it is ZA plus ZB plus ZC. In denominator, it is ZA plus ZB plus ZC square. So, you can cancel this. So, the remaining terms here are what are the remaining terms? It is Z1 into Z2 plus Z2 into Z3 plus Z1 into Z3, which is equal to ZA into ZB into ZC whole divided by ZA plus ZB plus ZC. So, from equation 1, we know that Z1 is equal to ZA into ZB divided by ZA plus ZB plus ZC. So, when you compare equation 1, and I call this equation as 5, when you compare equation 1 and 5, you can equate it as Z1, because ZA into ZB divided by ZA plus ZB plus ZC into ZC. So, from this equation, we can tell that ZC is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1, the whole divided by Z1. That is nothing but, if you want to find out equivalent delta network terminology, that is ZC, ZC will be equal to Z1 into Z2 plus Z2 into Z3 plus Z3 into Z1 divided by Z1. So, in simple terms, if you want to find out the delta network, that is ZC, then you need to take a summation of all two possible combinations. Here the given impedances are Z1, Z2 and Z3. The summation means all two possible combination means, that is Z1 into Z2 plus, that is summation, plus Z2 into Z3 plus Z3 into Z1 divided by, if you want to find out ZC, opposite to ZC is Z1. So, ZC will be equal to opposite, denominator will be equal to Z1. Similarly, if you want to find out ZA, ZA means numerator will be once again the same, that is the possible combination, the summation of your possible two impedances, that is Z1 Z2 plus Z2 Z3 plus Z3 Z1 whole divided by, now you need to determine ZA, opposite to ZA is Z2. So, the denominator will be equal to Z2. Similarly, if you want to find out ZB, then ZB is equal to, numerator will be same, that is Z1 Z2 plus Z2 Z3 plus Z3 Z1, the whole divided by, now for ZB the opposite resistance is Z3. So, the denominator will be equal to Z3. This is how we convert our delta network into a star network, or star network into a delta network. Now these equations are corresponding to star to delta, that is Z1, Z2, Z3 are known. So we will be determining ZA, ZB and ZC. So the formula is ZA is equal to the summation of all the two possible combinations, that is Z1 into Z2 plus Z2 into Z3 plus Z3 into Z1 divided by opposite resistance. If you want to find out ZA, the opposite resistance is Z2. Similarly, if you want to find out ZB, the numerator once again it will be the same, the denominator will be the opposite impedance. The opposite impedance here is Z3. Similarly, if you want to find out ZC, then ZC will be equivalent to, numerator is once again the same, that is the summation of two possible combinations of your resistors and divided by the opposite resistance. The opposite resistance for ZC is Z1. This is how we convert a star to delta network. In yesterday's class we have already learnt about how to convert a delta into star, that is Z1 is given by, what are the two terminals connected to Z1, that is ZA into ZB divided by summation of all the impedances, that is Z1 is equal to ZA into ZB divided by ZA plus ZB plus ZC. Similarly, if you want to find out Z2, for Z2 the two impedances connected are ZB and ZC. So it will be ZB into ZC divided by ZA plus ZB plus ZC. Similarly, if you want to find out Z3, the elements connected to Z3 are nothing but ZA and ZC in your delta network. So it will be ZA into ZC divided by ZA plus ZB plus ZC. So these three equations are governing for delta to star. So these three equations will be for your star to delta transformation. Why we do star and delta transformation? Just to replace it with an equivalent network or to simplify the network. So what is the thing? For the delta to star conversion, each resistor in the star is equal to the product of the resistors in the two adjacent branches divided by the sum of all the three delta resistors, that is two adjacent branches are ZA and ZC divided by summation of all the resistor. Similarly, if you want to convert from star to delta, this will be your star to delta equation, which will be equal to the sum of product of the star resistors taken two at a time divided by the opposite resistor. That is, if you want to find out ZA, then it will be the summation of product of star resistors taken two at a time. That is, if you want to find out ZA, Z1 into Z2 plus Z2 into Z3 plus Z3 into Z1 divided by opposite resistance. For ZA, the opposite resistance is Z2. Similarly, if you want to find out ZB, the opposite resistance is Z3. For ZC, if you want to find, the denominator will be the opposite resistor, that is Z1. Now I think you are comfortable with how to convert star to delta or delta to star. In yesterday's class, we spoke about the series parallel combination of resistors, and we also spoke about how to transform a current source into a voltage source or a voltage source into a current source, and we also learnt about a method called source shifting. The source transformation is possible only for your practical sources. If there is an ideal source, then we can use a method called source shifting so that you can simplify your circuit. And we also read about star delta and delta to star transformation. Today, now we will be doing few problems on series parallel combination of resistors and source transform, few problems on source transformation or star delta transformation. Whatever the concepts you have read till now, it is for general principle, it is applicable for all the circuit, it is not meant only for one single circuit, it is a general principle. So now I will take a problem. In this problem, the question is stated that for the given circuit, calculate the value of current in either branch and the value of unknown resistance R when total current taken by network is 2.25 amps. So you can see the circuit there, which has So in your question it states that calculate the value of current in either branch. Calculate the value of current in either branch means there are two branches here. I need to determine I1 and I need to determine the current flowing in this branch. I will call it as I2. You need to determine the value of current I1 and I2, and you also need to find the resistance, the unknown resistance here, that is R ohm. And in your question it is stated that when total current taken by network is 2.25 amps. 2.25 amps. So we need to simplify this problem. We need to determine the resistance R and we need to determine the current I1 and I2. You can see this 2 ohm and 6 ohm are in series. So you know the series principle. Whenever two resistors are connected in series, then you need to sum it up. So if you sum it up, 2 plus 6 will be equal to 8 ohm resistor. Similarly, in this branch, this 5 ohm and R, unknown resistance R, it is in series. So when you sum it up, it will become 5 plus R ohm. So this is connected to your 10 volt source, and the current flowing in this from the source is 2.25 amps. Now the question is to determine I1 and I2. With respect to, if I call this node as A and this node as B, with respect to node B, the potential at A is 10 volts. So you know your Ohm's law, that is, if you want to determine the current flowing in this branch, I1 will be equal to V by R. That is, I1 is equal to, what is the voltage applied? That is 10 volts. 10 divided by 8, which is equal to 10 divided by 8 is 1.25 amps. I1 will be equal to 1.25 amps. Now we have determined the current flowing through your first branch, that is I1. Now I need to determine the current flowing in your second branch, that is I2. You know that KCL states that algebraic sum of incoming currents is equal to algebraic sum of outgoing current. The incoming current in this node is 2.25 amps, which is equal to the currents leaving at this node. The current leaving at this node are I1 and I2. So it will be equal to I1 plus I2. And we already know that we have calculated what is I1. I1 is equal to 1.25. So from this I1 we can calculate I2. I2 will be equal to 2.25 minus I1. I1 given as 1.25 amps. So I2 will be equal to 2.25 minus 1.25, which is nothing but 1 amp. Now in this question we have determined what is I1 and what is I2, and in your question it also states that you need to determine the value of the unknown resistance R. So unknown resistance R in this branch we need to determine. So it is, once again you use Ohm's law application, that is V is equal to I into R. What is voltage applied at this node with respect to B? That is nothing but 10 volt, which is equal to current flowing in this branch. The current flowing in this branch is I2. We have already calculated the value of I2, which is nothing but 1 amp into the resistance. What is resistance given here? 5 plus R. That is 5 plus R. If you simplify this equation, you can determine the unknown value of the resistance. That is, R is equal to 10 minus 5, where R is equal to 5 ohm. So this is a simple network where in your question it has stated that you need to determine the unknown current I1, you need to determine the branch current I2, and also you need to determine the resistance R. We have used an application of series network, as 2 and 6 are connected in series. So it will be the summation of two resistances, that is 2 plus 6 will be equal to 8 ohm, and 5 and R are connected in series. This will become 5 plus R, and your circuit is energized with 10 volts and your source current is of approximately 2.25 amps. Then how to determine I1 means, that is branch current 1, I1 is equal to V by R. V given in your question is 10 volts and R given is 8 ohm. So 10 by 8, which is equal to 1.25 amps. Your source current is 2.25 amps. If you subtract the branch current, the first branch current, that is 1.25 amps, then you can determine the second branch current, that is I2 is equal to 1 amps. Then we need to also determine the unknown resistance R. The unknown resistance R, V is equal to, we have used Ohm's law once again, V is equal to I into R. The voltage applied is 10 and the source, the current flowing there is I2 into R. The current flowing in this branch is I2, which is equal to 1 amp into the resistance. The equivalent resistance here is 5 plus R. So in this equation I have taken it as 5 plus R. So if you simplify that, R will be equal to 10 minus 5, which is equal to 5 ohm. We will go to next problem, which is on source transformation. The question states that obtain a single current source for the network shown. In last classes we have already read how to transform a current source into a equivalent voltage source or a practical voltage source into a equivalent current source. In this question it states that obtain a single current source for the network shown. In this circuit it consists of two practical voltage sources and which we need to convert it into a single current source. So a question is given like this: there are two practical voltage sources which we need to convert it into a single current source. So we know that in source transformation the important points to be known are, we can convert only a practical voltage sources. If it is a practical, if it is a ideal current source or a ideal voltage source, we can't convert it. And one more thing is, we need to think about the polarity. Polarity plays a very important role. First I will be converting this practical voltage source into a current source. So how to represent a current source, practical current source? If you are transforming it from voltage source to current source, it consists of a current source in parallel with a resistance. The magnitude of this current is given by I is equal to V by R, which is nothing but, in your question it has told that which has a voltage of 18. So which will be equal to 18 by your resistance. R is given as 6 ohm. So 18 by 3 will be equal to 3 amps. This current source has a magnitude of 3 amps. And what will be your parallel resistance? Your parallel resistance will remain as your source resistance in your voltage source. That is, even here it is given as 6 ohm. Your parallel resistance will become 6 ohm. Now I will convert your second voltage source. In this second voltage source, the polarity is in the opposite direction. So whenever you write a current source, it should be in the negative opposite direction. That is, it is flowing in the downwards direction. So then you have, once again you need to represent a source resistance. The source resistance will be same in both the cases. In your question it is stated as 5 ohm. So even here it will be equal to 5 ohm. And the value of this current source will be equal to V by R. That is 10 by 5. 10 by 5, which is equal to 2 amps. So we have converted a practical voltage source into a practical current source. Now we can see that there is a 3 amps current which is flowing from downwards to upward direction, and similarly there is a 2 amps current which is flowing from upward to downward direction. In yesterday's class we also learnt about how to convert 2 volt current sources connected in parallel, or if there are 2 voltage sources connected in series. We have already learnt that if 2 current sources are connected in parallel, then we need to sum it up with the proper polarity. Here the major current flowing is from 3 amps, here it is 2 amps. 3 minus 2, it is in the opposite direction, so it will become 3 minus 2. So the effective current flowing here is 1 amp. That is, 3 amps is from downward to upward direction, and your 2 amps is from upward to downward direction. Both are in opposite direction. So 3 minus 2, which is equal to 1 amp current source. Then we have two resistances, that is 6 and 5 are connected in parallel. How to determine equivalent resistance in a parallel network? We know that R equivalent will be equal to 6 into 5 plus 6 plus 5, which is nothing but 30 by 11. 30 by 11, you can also write it as 2.73 ohm. 2.73 ohm. This is 2.73 ohm. See, in your question, once again I will tell you, you need to determine a current source, a single current source for the network shown. In this question, there are two practical voltage sources. So, we need to convert it into a single current source. That is our task for this question. So, how to convert your voltage source into a current source? We know that a current source in parallel with a resistance. The magnitude of this current is given by I is equal to V by R. The voltage given as 18 and the resistance is given as 6. So, 18 by 6 will be equal to 3 amps. The magnitude of this current source will be equal to 3 amps in parallel with a resistor. The resistor value of this will be equal to your source resistance, which is nothing but 6 ohm. Similarly, you need to convert this practical voltage source into a current source. So, once again we need to think about the polarities. So, in that particular direction we need to mark the current flow. So, it is from the magnitude of this current will be equal to V by R, that is 10 by 5. 10 by 5 which is equal to 2 amps, and in parallel with the resistance will be equal to your source resistance, which is nothing but your 5 ohm. And in this circuit you can see there is two current sources which are connected in parallel. You know, if two current sources are connected in parallel, then you can add it up, but it is in opposite direction. So, we are taking it difference, that is 3 amps minus 2 amps will be equal to 1 amp. Then these two resistors are connected in parallel, that is 6 and 5 are connected in parallel. So, 6 into 5 divided by 6 plus 5, which is equal to 30 by 11, which is nothing but 2.73 ohm. We will go to next problem. So, in this question we need to convert this circuit into a single voltage source. So, you can see the question, you need to convert this into a single voltage source. Here there is an 8 amps current source in parallel with a 4 ohm source resistance. There is one more current source which has 12 amps in parallel with a 6 ohm resistance. In a simpler way, I can change this circuit, a current source in parallel with a resistance, then there is one more current source in parallel with a resistance 6 ohm. This is 4 ohm, this is 8 amps and this is 12 amps. Now, you know how to convert a current source into a voltage source. That is, if you want to convert a current source into a voltage source, then it will be a voltage source in series with a resistance. The magnitude of this voltage will be equal to V is equal to I into R. In this question, the current is stated as 8 amps into the resistance given here is 4 ohm, which is nothing but 32 volts. The magnitude of this voltage source will be equal to 32 volts. Similarly, the resistance here will be equal to as of your source resistance in your current source, which is nothing but your 4 ohm. Then we will try converting this second current source in parallel with a resistance. Once again, it is nothing but a source resistance in series with a voltage source. The resistance will be same as that of your source, that is nothing but 6 ohm, and we need to calculate the magnitude of this voltage source. V is equal to I into R, that is 12 into 6, that is I is equal to 12 and your resistance given as 6, which will be equal to 72 volts. The magnitude of this voltage source is 72 volts and the resistance will be same as your source resistance, that is 6 ohm. Then now you can see here there are two resistors are connected in series. If two resistors are connected in series, then you need to sum it up. So, that will be equivalent to, if you add two resistor 4 plus 6, it will be equal to 10 ohm resistor. Then there are two voltage sources which are connected in series. We need to see the polarity. As both the polarities are in the same direction, then you need to add it up, that is 72 plus 32. 72 plus 32 is 104. You have a voltage source which has a magnitude of 104 volts. This is the equivalent or single voltage source, whatever the question you have, in your question it has stated that we need to convert this circuit into a single voltage source in series with a resistance. That is our question. So there are two current sources, two practical current sources, and we need to convert it into a single voltage source. We know the formula how to convert a current source into a voltage source. If you want to convert a current source into a voltage source, then it will be a series combination of your voltage source in series with a resistance. The resistance will be same as of your source resistance, and the magnitude of voltage will be equal to I into R. In your question, I is given as 8 amps and the resistance is given as 4 ohms. Then it will be equal to 8 into 4, which is nothing but 32 volts. Similarly, I have converted the second one, which will be equal to 6 ohm and 72 volts. As these two resistors are in series, then it will be equal to 6 plus 4, which is the equivalent resistance will be equal to 10 ohm. As 6 and 4 are connected in series, you need to add up. Similarly, there are two voltage sources in series, that is 72 volt and 32 volt. So you need to sum it up, which will become 104 volt. We'll go to next problem. Now we will take a bit huge circuit with a lot of elements. So in this, which has both current sources as well as practical source, voltage sources. In this circuit, we need to reduce it into a single voltage source by the method source transformation. In this question, you can see there is a current source in parallel with the resistance. The magnitude of your current source is 10 amps and 2 ohms, which is connected to a 5 volt source in series with the resistance. Okay. In this circuit, we have multiple current sources and multiple voltage sources, that is practical sources. You need to convert it into a single voltage source, that is our question. So in this, you can see there is a practical current source, that is a practical current source can be converted into a equivalent voltage source. That is how to convert. We know that a resistance in series with a voltage source, that will be our practical voltage source. How to convert? The resistance will be same as that of your source resistance, which will be equal to 2 ohm. The magnitude of this voltage will be equal to V is equal to I into R. The I given here as 10 into 2, which will be equal to 20 volts. Similarly, in this circuit, there is a 5 volt source in series with a resistance. Here you can see there is one more voltage source where you can convert it into a equivalent current source, and the polarity we need to think about that. Here the polarity will flow in downward direction in parallel with the resistance. This practical voltage source, I am converting it into a equivalent current source. The resistance will be same as that of your source resistance, which is nothing but 2 ohm, and I is given by V by R, which is nothing but V given here as 10 by the resistance, which is 2 ohm, which is equal to 5 amps. Then we have one more resistor which is in parallel, which is equal to 4 ohm. We have a current source which is flowing in the upward direction, that is equal to 5 amps, and you have one more voltage source that can be converted into a equivalent current source. Equivalent current source means you need to have a current source in parallel with the resistance. The resistance value will be same as of your source resistance, which is equal to 4 ohm, and the magnitude of this current will be I is equal to V by R. I is equal to V by R. V given as 20 by 4. 20 by 4 is 5 amps. This is the simplified circuit now. Further, we can see that there are 3 current sources connected in parallel. I will call this as I1, I2 and I3. So, as I1, I2, I3 are connected in parallel, you need to add it up, you need to sum it up. But in this you can see 2 currents are flowing in, this I1 is flowing in negative direction and I2 and I3 in positive direction. So, the total current I will be equal to I2 plus I3 minus I1. So, I2 is nothing but 5, I3 is equal to 5 amps minus your I1 is in the opposite direction. So, I will take it as minus 5, which is equal to 5 amps. So, I can simplify these 3 current sources into a single current source. So, your circuit reduces to a voltage source, and these 2 voltage sources are connected in series, but in different opposite polarities. So, if you start from here, it is in the opposite direction. So, you can write it as 20 minus 5, which will be equal to a 15 volt source. You can reduce these 2 voltage sources, as it is connected in series, you can reduce it to a single voltage source, and it is in opposite polarities. So, it will be a difference, that is 20 minus 5 will be equal to 15 volts. Then this 2 ohm, I will call it as R1 and R2 are connected in series, because same current flows in it. So, as R1 and R2 is in series, you can once again add that, that is 2 plus 2 will be equal to a 4 ohm resistor, and there is a current source. We have determined the current source. As 3 current sources are connected in parallel, you can sum it up. As 3 current sources are connected in parallel, the effective current source will be equal to 5 amps. The magnitude of this will be equal to 5 amps, and you can see here this 4 ohm, I will call this as R3, R4 and R5. As R3, R4 and R5 are in parallel, you need to determine the equivalent resistance. That is, you know that 1 by R is equal to 1 by R3, that is 1 by 2 plus 1 by 4 plus 1 by 4. So, R will be the inverse of R will be the effective resistance. R will be equal to inverse of that, which is nothing but equal to 1 ohm. So, you need to represent a 1 ohm resistance in parallel with the current source. So, in further simplification, so you have a current source here, a practical current source, you can convert it into a equivalent voltage source. So, it will be equal to which is equal to, here V is equal to I into R. So, it will be 5 volts, V is equal to I into R. I is 5 and R is equal to 1. So, it will be 5 into 1 will be equal to 5 volt source, and the resistance will remain same, that is nothing but your source resistance, which is equal to 1 ohm. You can see here this 15 volt and 5 volt are connected in series, but it is in opposite polarity. So 15 minus 5, you can reduce it to a single voltage source, which will be equal to 15 minus 5, which is equal to 10 volts, because these two voltage sources are connected in opposite polarity. If you start from this direction, 15 minus 5 will be equal to 10 volts, and this 4 ohm and 1 ohm is in series, so it will become 4 plus 1, which is equal to 5 ohm. 5 ohm resistor in series with a 10 volt voltage source. So in this, whatever the concepts we have read, that is source transformation or the series parallel network, with that huge circuit, we have simplified it to a single voltage source in series with a resistance. That is the importance of your network reduction techniques. And we'll see next problem. Using source transformation, find the power delivered by 50 volt voltage source in the circuit shown. This is 5 ohm and this is 50 volt. So the question is, using source transformation, you need to find the power delivered by the 50 volt voltage source. So what is power? Power is given by P is equal to V into I. I know the value here, whatever the voltage here, that is 50. The unknown term here, I need to determine the current flowing from this voltage source. So I need to first simplify the circuit. I can also redraw this circuit as you can see here, with respect to point A, your current source is from, if I take this as earth or ground, with respect to ground, your A has a current source, that is 10 amps. So in this circuit also, if I take this as ground, this is A, it is nothing but the same. I have redrawn the circuit in a simpler way. So now you can see there is a practical current source, you can convert it into a equivalent voltage source. So when you are converting it, your circuit simplifies like this. So how to convert this practical current source into a voltage source? A resistance in series with a voltage source. The resistance will be same as of your source resistance, which is equal to 2 ohm, and V is equal to, the magnitude of your voltage will be equal to V is equal to I into R. That is, I is given as 10 into resistance is 2. 10 into 2 will become a 20 volt source. Similarly, there is one more voltage source, which is 3 ohm, 10 volt. Now we have 3 voltage sources, so you can determine your current flowing from your source. With the help of Kirchhoff voltage law, you can determine the current flowing in this two circuit, in the two sub branches, or you can convert it into everything into a equivalent current source. Equivalent current source means, I am showing the other way of the problem. So this is 5 ohm, which is connected to a voltage source 50 volt. Here it is 5 ohm. You can leave this 1 amp source as same in parallel with the resistance 2 ohm. The another style of doing the same problem is, you can convert this practical voltage source into a equivalent current source, that is a current source in parallel with the resistance. So the magnitude of this current will be equal to I is equal to V by R, that is 10 by 3. The value of this current source will be equal to 10 by 3, which is nothing but 3.33 amps. So the value of this resistance will be equal to 3. So you can see that 10 amps and 3.33 amps are in the same direction. So you can further reduce it as 10 amps and 3.33 amps are in same direction. So you can sum it up, which will be equal to 13.33 amps, and these two resistance are in parallel, that is 2 and 3 are in parallel. So it will be become 6 by 2 into 3 by 2 plus 3, that is 6 by 5. Further you can reduce it into a single voltage source, that is a 50 volts in series with a resistance, that is 5, and you can convert this into a equivalent voltage source. If you are converting it into a equivalent voltage source, then your circuit is like this. The value of this source resistance will be equal to 6 by 5, and the value here, that is voltage, will be given by I into R, that is 13.33 into 6 by 5. Here the resistance 6 by 5 is nothing but 1.2 ohm, and the voltage will be equal to 13.33 into 6 by 5 will be equal to 15.996 volt. Our question is to find the power delivered. P is equal to V into I. I need to find the current flowing here. So if you apply KVL here 50, and one more voltage source here is minus 15.996 and divided by the resistance. There are two resistance, 5 and 1.2 are connected in series. So it will be 1.2 ohm, which is equal to 50 minus 15.996 divided by 6.2. 5 plus 1.2 will be equal to 6.2 ohm, which is nothing but 5.48 amps. Our question is to determine the power, which is equal to the voltage here is 50 into 5.48 amps gives you the power, that is 50 into 5.48 is 274.2 watts. The unit of power is watts. So we have done with our question. Our question has stated that we need to find the power delivered by 50 volt source. That is, we know the voltage, we need to determine the current flowing here. That is, P is equal to V into I, and we have simplified the circuit and we have determined the current. The current flowing from the source is 5.48 amps. So P is equal to V into I, which is nothing but 50 into 5.48, which is equal to 274.2 watts. And in this class today, in this session, we have done few problems on source transformation or network reduction techniques. Using network reduction techniques, we have done few problems. In next session, I will be doing further more problems so that you will get the concepts clear. Thank you.